Hey y'all, and welcome back to our Grasshopper set of tutorials. This is going to be tutorial number 3, but just sort of to recap where we left off with the last one, I'm going to open up the old Grasshopper script here. So this was the surface we made the last time. As you can remember, we sort of contoured it. We had 3 or 4 curves on the inside that were originally lofted to create the form, and then some points on the outside. And you can see sort of how a wave is rippling out away from there. So if you remember, we used surface normals. Those are perpendicular points away from the direction of the surface at that given point. This was the script. And we offset the points based on sort of the graph mapping function. So like I said, we had our normals. We divided our surface. We used our original curves here. Actually, I can go back in and I can delete the surface that I baked. So we had 4 curves originally that we lofted surface through, and then we offset another one so that we had an inside and an outside. You can see this is the outside, this is our inside. And then we divided that surface the same way that we did in our first tutorial. We used the normals at each one of those given points that you can see right now, and we created a sinusoidal wave function that was sort of radiating around those 4 points you see floating around those curves. And from there we were able to go back through and use those as the amplitude to which we can move those points closer to or away from the original lofted surface based on those normals. So from there we actually took and created a surface through those points, and they were in the same structure as the set before, so that's important to note for later. And then we took and we created a contour through that new surface and then the surface we had originally lofted, so that we had our inside and our outside curves that we could then take to the laser cutter and cut. So today we're actually going to go through and do a new surface. This is basically an alternate version of the same thing. But it's going to show you some data structure, and I think it'll be really, really nice to sort of start understanding what Grasshopper does behind the screen or inside those boxes, and maybe we'll get a better sense of exactly what's going on. So I'm going to go back through and I'm deleting all of these old boxes, part of the old script that we don't need. Keep the surface from points and the addition and slider plugged into it, so I'm going to select everything but that right now. Sorry, my mouse is a little finicky. And I'm deleting those things. So like I said, we want to keep the surface from points, the U count, the addition block plugged into it, and the number slider. And then we're also going to keep our contour, our original surface, plugged into that, and the offset value that we have, or the distance value we have between those contours, because those will come in handy again at the end as well. So now I'm just going to go back to the beginning here to just sort of show you where we're at. We have our 4 original curves, our loft, our offset, our number slider, and our other number slider. So those are all going to remain important. We're going to use those to drive this Grasshopper script. But we're going to use them we're going to do some different stuff with the points that we get from our divide surface. So actually, a lot of this came from what I saw. One of my teachers has a coffee mug. And it's kind of spiky. It's made out of ceramic. So actually I'm going to show you that file now. And I can go down to my file browser here. Just disregard all of this for just a second here. You can see my extremely organized file system. Anyways, so it was super spiky, and basically what I thought it did, or when I looked at it, I realized that it'd be pretty easy to build into this different file system. So what we're going to do is we're going to look at the shape of that first, so we can understand where we're going. And I think that's important a lot of times with Grasshopper, because where we want to go sort of is a defining characteristic of how we're going to get there. And if I don't show you what we're going to do before we do that, it's going to be really hard to tell what's going on along the way. So right now I'm just opening up Grasshopper. I get these weird warning messages because my plugins weren't installed correctly. That's my fault. And then I'm going to go in and I'm going to open the Grasshopper file that I used to create this surface. So I'm going to open the file. It's not in my recent files, unfortunately. And I'm going to open up spike shell, which is what I called it, because it kind of looks like a shell with some spikes on it. So you can see this. This is essentially what the coffee mug looked like. He actually used a couple of different things in order to create some variation in how far in or out the spikes were sort of extruded. And actually what I think I might do is I'm going to go to my display settings and I'm going to open up my mesh quality and I'm going to move that to document quality to just make sure that you guys can see this a little more clearly. So I'm going to click on that, but my Grasshopper script's in the way, so I need to minimize that. Here we go. So and now that we've upped the preview quality, you can really see this organic form that starts to take hold from these offset spikes. And I really like the texture of it. But more than that, I think it's a significant way to learn sort of data structure and how to think about Grasshopper points in a way that maybe we wouldn't have if we weren't trying to create something like this. So I can actually close this script here in a second, but I think it's important to see sort of what we're going to do. So we're going to take some of those points that we had from our divide surface command and we're going to move them in, and we're going to take some of those points and we're going to move them out, and that's going to create our spike. And then we're going to loft a surface through those things. But it's going to be important for us to do that in a way that manages the data effectively, so that when we go through and we loft that surface, all of our points come back in the right order compared to when they were divided. So anyways, this is the script that we're looking at now. So we have our points, and we have our normals, and we have our parameters. And what we're going to want to do is we're going to want to split the list of points into two different sets. We're going to have a really nice command for this called dispatch. And dispatch is going to take and split our list into two. So I'm going to connect that up now. But what you're going to see is that dispatch right now, and I'm going to type points so that we can preview each one of those things. Dispatch right now is splitting the list based on the existing tree structure. So originally we had probably a few branches of like several sets of points. But what we're going to actually go in and do is, so we had 31 values in each one of those. And you can see that here I have a panel open. That's just one of those ways to view data from the top. So we can see that we have all of these different points, and then each one is sort of separated into its own list. And there are a lot of values, so it's really quickly scrubbing through all of those things. So actually what we really want to do is we want every other point of the entire list, not just every other list per branch. So what we can go through and do is we can take and we can flatten those points. So now we're actually getting every other value of the entire list, right? So instead of having 1, 2, 3, 4, we're going to have 1, 3, and then we're going to have a separate list of 2 and 4, and that's what you're seeing in list B and list A. So I think that's really important because when we're going to take and create sort of geometry through these points, we're going to want to have them in an appropriate structure to do that. So now what we're going to go through and do is we're going to use a command called Orient in order to sort of move these points around. Like I said, dispatch is like a tool that we have in our set of commands up top there. You can see in the set tab. But what it does is it takes and it organizes data, or it splits it and it merges it together. Now we're having our original lofted surface and those points dispatched into two separate lists based on this new structure. And we don't need these points at the beginning now that I'm seeing that. We can get rid of those. So now we're looking at our dispatch, which shows all of the different values, and we're going to sort of move those points in or out. So what we're going to need to do is we're going to need to use a different command called Orient. Like I said, we have 481 values of, I think, 960 total. So just sort of looking at those in 3D space. So now we're going to use Orient. And it's important to note that Orient is a command that takes something from a source and moves it to a new location. And it does that using planes. So maybe that's something important to think about in Rhino. You can see that we have these gumball arrows moving out away from each one of the axes of the point. So we know that we have our X, our Y, and our Z, and but those just aren't by themselves enough to locate these things. We need these rotational sets of data too. We need to know how the plane is oriented in 3D space in order to place it in 3D space. You know, like a plane has a direction to it. It's a lot like a vector. So we need a source, we need a target, and we have our geometry. You know, those are just the points. So we need to generate planes, and we need to do that in a way that's going to give us the data in a structure that we want. So we're going to, and just sort of still thinking about these points. So you know, like we want, you know, like these axes by themselves are good, but they're just not enough. So like I said, we're going to need to generate something that can hold rotation information at the same time. So what we're going to do is we're going to take and create plane normals. The plane normal box is going to create a plane at a given point. That's our origin. So we're going to connect that up. And it's going to, well, actually, why don't we look at this first? So if we don't connect anything else to it, it's just creating a plane at every single one of those points. And that may be sort of hard to see, so I'm going to blow it up. I'm going to scale it up. Maybe that's not enough. It's going to take a second here to regenerate. So that's pretty good, but I'm going to blow it up a little more just to make it a little more obvious. Anyways, so now while this is regenerating, and hopefully it doesn't crash my computer, we can sort of see what's going on with all of these different points. So each one is flat. It's on an XY plane, right? So they're oriented to the rotation of maybe that work plane we can see at the bottom there, right? I'm trying to see it. It's kind of hidden. There it is. So it's with the green and red lines. And basically it's just orienting based on the world that this thing is existing in. So if we connect up our z-axis, right, from normals to z, because that's going to give us our direction or our vector away from the inside. And wow, it's actually slowing down my computer a significant amount. But that's because it's creating a multiple set of normals at each one of those points. It's creating probably 31 because that was our original tree structure. So what I'm going to want to go in and do so that it doesn't crash my computer is I'm going to flatten that list. So it's in the same structure as our points coming in. And now you can see that we have each one of those planes facing away from the surface, right? It's almost making a surface out of those planes. You can see that the normals are, you know, like all aligned with where the surface was before. And hopefully this makes a lot of sense. If we look at it, you know, if we sort of orient around, we can tell that basically these planes are creating the shape that we have lofted, which is pretty great. But like I said, we also need to have a target, right? So those planes on their own are good, but they're not really enough. We need to sort of alter those. And what we're going to do is we're going to actually dispatch those planes the same way that we have in our list above. So we have our new plane dispatch, and we have our other point dispatch, and I'm going to move those next to each other just so it's a little clearer. So if we look at these points, we can see that we have, you know, a point like right there, and we have a point at the same spot in list A. So dispatch 1 for our points in list A has 3 sets of data per point. It's got our X, Y, and Z location. And, you know, that's good for just a point, but if we look at list A in our second dispatch command, it's got all of the same information, and it also has a rotational value at each one of those points too. So we have our O and Z. Our O is our coordinate, and our Z is our rotation. So now you can see that. So we have the same number of values in each, 481, right? We have 481 in our first list. And it's just important to think about what's going to be going on at each one of those points and how we can sort of manipulate that. So again, we have our shape. And we want to move those things in and out rather than just being one direction away. We don't want them going up or on the z-axis. We don't want them going on the y-axis. We don't want them just going on the x-axis. We want them to move relative to the normal of the surface. And that's why we created our planes. So now we're going to create a plane offset block. So it's pretty nifty that we have that. Plane offset is going to allow us to just move those planes in the direction that we want them to go. So we have our first list and we have our second list. And we're actually going to, I think, want to do two different things with each one of those. So I'm going to create probably two of these plane offsets and I'm going to connect each one up. So here's list A. And we can see that there's no data plugged in for our amount of offset. So I'll plug in list B. But we want to do two different things with these, right? We want some to move in and we want some to move out away. So I'm just clarifying all of our data now. So we have list A, we have our points. List B, we have our points. Our plane offset for list A, our plane offset for list B. So that it's all clear. All of our data is in the same structure, right? And that's important. That's what we want to learn today is that if we're splitting our lists or if we're doing things at two separate times, we want to do them the same way. Okay, so now I'm creating a negative block, and what that's going to do is I want to offset those things by a number. So I'm going to type number, and I'm going to plug a slider into this eventually, but for now I'm just going to plug it into the negative value and our offset. So right now, whatever value we plug into this, right, so say I create a slider, I think I have one at the beginning, right here. I can move this back and I can plug it into our number, like that. And what it's doing is it's offsetting our second list negatively, so towards the inside, and it's going to be offsetting our first list towards the outside. So we can see that these have moved in past our original curve. And then we can see that this is going to have moved our other planes outwards, away from our original curve. Okay, so all of this is great, and we have a lot of information and parts, and they're in the same structure, which is good. But really what we're going to want to do is we're going to want to orient these things now. So now we can use our planes, right? We have our geometry, our source, and our target, and we can go and we can connect up our lists for our original planes, our original points, to where we want them to go. So what I'm going to do is we're going to connect plane, or actually I'll probably just connect up point first, but I'm going to do it one list at a time so we can really see what's going on. So I'm going to connect our point to our geometry. I'm going to connect our plane offset. This is where the planes have been moved to, right? I'm going to connect that to our target because our points aren't there yet, and I'm going to connect our original list A planes to our source. So now we can see that if I click on this, it's moving our points from the source to the target. And that means it's moving it from the planes that have like right up against that lofted surface we originally created away. But I'm going to plug in the rest of our data, and it looked a little funky there for a second, but basically without our other lists in there, it didn't make any sense. So our data wasn't matched. And a lot of times I think that's what we're going to run into with Grasshopper, is that sometimes it's going to be hard to match up our lists, but when we do, we can really start to understand what's going on. And I think it really becomes clear once we've seen something like this, where we have to match different types of data or the same types of data in a similar structure. So now we can see that we have some sort of thickness. We can see our inside points and our outside points. And we actually have a block that we have left from the beginning, right? We have our create surface from point. So I'm just going to move that back up towards where we're working. And basically what we're going to do is I can take these points now and I can create a surface from those points, right? Because they're in the same structure that they were at the beginning. Or, maybe were they? And that's going to be our challenge. So right now it's sitting and it's waiting, and we're going to have to wait on it for a second. But while it does that, I'm going to explain maybe what the problem is going to be when we connect up our surface from these points. So if you remember, when we originally divided our surface, we had an even grid, and then we split our list in two so we can move some of those points in and some of our points out. And fundamentally, that's where our problem is going to come from. So instead of just having our lists where our points are sorted properly, right? We had our original list of 1, 2, 3, 4, and we split it into a list of 1, 3, and 2, 4. Now our list structure is going to be 1, 3, 2, 4 because we have our first list and our second list. And what that's creating for us is basically like this Mobius surface inside of our lofted form. And that's not really like helpful to anything that we're doing. We want our data organized in the same way that our surface was originally divided by. So we're going to disconnect this before it breaks my computer. Maybe it will, who knows. Wow, this is taking a really long time. Anyways, we're going to take and we're going to sort our geometry in order to get back to this original list structure that we had. It's nice because our points are already flattened and everything's already ready for us at the finish line. We just need to organize ourselves before we get there. So what I'm going to want to go in and do, and actually I'm just going back to our just to walk through what we had done before, is we're going to want to find the length of our list, right? So we want to find the length of our first list A so that we can go in and actually separate out our lists of geometry into two lists again and then put them back together. So we have 961 values, but we know that our original list was like 481, I think. I don't remember. I'm just guessing at this point. And we're going to go in and we're going to make sure that our data is organized properly. So we want to make sure that instead of having like one list of one and one list of another, we following each other. We have one list that goes 1, 3, 2, or 1, 2, 3, 4 rather than 1, 3, 2, 4, because our first list 1, 3 got put after our second, or got put before our second list 2, 4. So right now our data is 1, 3, 2, 4, and we want 1, 2, 3, 4. Right? So hopefully you guys can understand the difference there. So we're going to split our list based on the length of our first list. Right? So we're going to have a list A and a list B, and they're going to basically be the same as they were before they were plugged into that Orient box. And that's going to be really important for our proper data structure. But just those two things separate aren't really going to help anything. And we could have done we don't necessarily need to do all of this. We can just plug in two different Orient commands and then weave it. But I just wanted to show what was going to happen if we had one box do all of it, and how to properly do it with one box rather than having two separate commands running at the same time, filling up more space in your script, and really understanding data structure in order to do that. I think it's a really good learning opportunity. So now what we want to do is we want to weave our two lists together. So list A, 1, 3, and list B, 2, 4, we want to weave into a list of 1, 2, 3, 4. So I can go up here to the set command and I can go to our list tools and I can have we have two streams. We have list A and we have list B, and we can connect that up. And we're not going to really see any change in what we were looking at before, but what we can do is, I'm just moving these back so it looks orderly, is we can understand what it's going to be doing when it gets plugged into the surface. So understanding data structure is a really important point for being able to debug our own Rhino scripts. So a lot of times I feel like we don't really know what's going wrong, and that's because or our own Grasshopper scripts. A lot of times we don't really know what's going wrong because we don't understand the data. But if we can understand what we're looking at in our lists, I think understanding our surfaces are going to be a lot easier. Now, initially this is going to look like it didn't work. It did. But if you remember, we blew up our surface really, really large, right? So we can still see that these things are oriented off each other, but by creating a surface through our points, it's actually approximating that. So what we're going to want to do, and I'm going back, I'm thinking about maybe editing the size of the slider. That's actually not necessary. The 2 is probably enough. So I'm just going to go back to the beginning here, or where we were at. I'm going to shrink down our curves that are driving this entire thing in order to reduce the density. I just blew those up. You don't actually have to do that. It's going to be really clear just in your file on your own. I just blew that up and I forgot to shrink it back down when I was showing you what was going on with our planes. So now that I shrink it back down and we look at it, I'm going to zoom in here. We can really begin to understand what's happening with our offset. I think that's a lot clearer. So now if I click on surface through points, we can really understand the deviation and the spikes and what's going on. And I can increase or decrease the amount that we're seeing. I can go back to the beginning there and sort of offset it. But what you're seeing at the top here is because there aren't any other points on the inside, right, on the top and the bottom, the surface is the surface through the points is a lot more exaggerated there. And similarly on the spine, they're not being balanced out by a point on the inside. So when we actually go and laser cut this, we're going to want to chop the top and the bottom off because we're not actually going to be able to make those. And it's also going to lead to probably an easier coordination of our different layers when we stack them. But just to review, we took our divide surface points and we created a plane at each one of those points relative to the normal of our lofted surface. So every single one of those points has a normal, and a normal is a vector perpendicular to a surface at a given point. So we went and we created a set of planes, right? Or we wanted to sort of understand what was going on there. So we have our planes. At this scale, it's a little hard to really understand, but trust me, it makes sense. And then we dispatch those planes and our points into 2 separate lists. And those lists have the same structure. And then we offset some points at the outside and the inside. We can really see that there. And then what we're going to do is we're going to use our original planes, our original points, as our geometry and our source. And then we are going to use our new planes as our target. And then the problem with that was our data wasn't in the same structure as it was when we divided our original surface, so we split our list back into 2 pieces. And then because they were sort of in a list structure of like 1, 2, 3, 5, 2, 3, or 2, 4, 6, and we really wanted a list that was 1, 2, 3, 4, 5, 6. So we merged our 2 streams together, like I said, and we can see that we have 961 values there. And we're going to look, and we split our list based on the length of our original list. So we had 481 items in the first list. So we split our list from 1, 2, 3, 5, 2, 4, 6 back into 1, 2, 3, 5, and 2, 4, 6 like separately. And then we wove them back together, so now that they were 1, 2, 3, 4, 5, 6. So now we have all of our data, and it's properly laced together and woven together. And that was enough to create the surface properly so we could loft our points through it. And that's just approximating the distance between those 2 points. So, and also we still have our contour tool here from the beginning. So I'm going to go over in a later tutorial how to use these contours. But basically what we're going to do is we're going to laser cut them, and then before that we're going to actually plug them into an unroll surface tool and lay them out. But for this, if we wanted to laser cut this, we could just get rid of the top and get rid of the bottom and not cut those layers, and we'll have a flat top and a flat bottom. So that's super helpful and pretty nice. But for now, that's sort of all we have. Video 4 is going to be about plugging in different scripts that we find on the internet and sort of how other people have probably solved the problems that we are looking to solve ourselves, and we're going to work on unrolling and separating out all of those different sets of curves so that we don't have to do it by hand. Anyways, I think maybe that helps. So hopefully you enjoyed learning about this sort of contour process. I guess we learned that the last time, but learning about this sort of spiky shape. and sort of seeing idea of how data works, and I think it'll give you a lot of tools going forward in your toolkit to sort of understand what's going on when we're looking at our scripts and trying to debug it. But that's all I got for this tutorial, so I hope you enjoyed, and let me know if you have any questions. Shoot me an email. I'm just going to save these, but I'm done for now. So I'm going to save this as O3 Spike Surface, and thanks for watching.